All right, in this video, we're going to be talking about inverse functions some more. So this is part 2 of 1.6. And so let's just pick up right where we left off, which is, let's do this warm up. Find the inverse of the function algebraically. And so what that is telling us to do is, first of all, we're going to rewrite the problem and replace f of x with y. And now to find the inverse, you just swap x and y. So we're going to put x there, and we get y minus 3. And then the only thing left to do is now just solve it back for y. So I would square both sides, and I would add 3. All right, so that is basically the answer. I say basically because all we want to do now is answer using the language of functions, which is we found that the function turned into this, but what was this function? It was the inverse. And let's think about this. We take a number, an f of x, we subtract 3, and then we square root. So to undo that, we would square whatever we got, and then we would add 3. Yep, exactly. Okay, let's move on to example number 5. Verifying the existence of an inverse function. All right. For part A, let's just do what we just did, and let's find the inverse. And so I'm going to rewrite the problem and swap x and y and solve for y. I need to take a square root here, so I need the plus and the minus. Okay. Now, would we call this a function? And the answer, I hope at this point we know, is absolutely not. So it would be inappropriate for me to now rewrite this. Okay, I'm going to say this is a bad thing. I'm not going to do what I just done the last problem and say this. Which isn't to say like that this doesn't undo, right? It does undo this problem, right? It does that to some degree, but it has a complication because we have something that is not a function. So when I plug in an x value, say 3, to this new thing I created, it could spit out 2 different answers, and that's not what a function does. A function has to spit out one answer. And of course, we know that with this plus and minus. So again, it's not to say it might not be a useful tool. It's something that we might need in an equation someday. But we have to recognize that what we have is not a function. And this notation right here is function notation. And so it would be inappropriate for us to write that statement. All right. So does this have an inverse function? The answer is no. No inverse function. But the key word there is function. Does it have an inverse equation? Does it have an inverse relation? Yes. This is the inverse relation. But that relation is not an inverse function. All right, let's graph both these functions. I'm going to use the word improperly, these equations. We know this is a parabola shift up 3. Therefore, through whatever method you want, either graphing what we got or flopping around x and y, we know that this is shifted over to positive 3 and is a sideways parabola. We have the top half and the bottom half of that quadratic. All right, so what makes this, like we knew going into this, it would not, the inverse wouldn't be a function. So what kind of a test could we run? Well, we know about our friend the vertical line test, right? If we pass a vertical line, then and it only hits one point, then we know that it's a function. Well, what happens to a vertical line as you reflect it over the line y equals x? It becomes a horizontal line. So one of the tests that you can run to see if a function is going to have an inverse function is you can run what's called a horizontal line test. So the horizontal line test is just really getting a jump on running a test on what you get, because again, if I do the inverse of all of this information, it simply becomes this sideways parabola, and that horizontal line becomes a vertical line. So running a horizontal line test on a function is just like running a vertical line test on its inverse. So horizontal line test. So what we're looking for is something called a one-to-one function, meaning that we know for a function like x values can go to the same y values, right? You can plug in, like again here, we have plugged in a number and it got a 4. We plugged in this and we got 4, right? That would make it not one to one. One to one is where only one x returns one y, so we don't have any repeats. So for example, x cubed is a one to one function because I have no repeated y values. Another way to think about this is a one-to-one function passes both a horizontal and a vertical line test. So I pass the vertical line test on this x cube graph, and we see that it passes and is a function, right? So we know it's that we know it's a function, and then we pass a horizontal line test on it, and we see if we only get one answer, right? Is that a function as well, right? When we flip it, and the answer is yes. So if it and its inverse are functions, we call it a one-to-one function. Passes the vertical and horizontal. All right, let's keep going. Or instructions. Verify the existence of a function and then graph it. All right, so I think I just did all of these. I wonder why I did it this way. There was probably a reason, or maybe oh, never mind. I missed the subtle difference. Okay, subtle difference. Here's what I want you to notice. Same function, x squared plus 3 as part A. But notice now I have put this restriction on the domain. So if I graph x squared plus 3, we're going to start by graphing it. We know it starts here. But now I'm saying only graph it for the positives. So this is this function f of x that they're referring to. Is f of x going to have an inverse? And the answer is yes. Since I have restricted the domain to only looking at one half of this, we see it passes the vertical line test, but we also now pass the horizontal line test. So that means it is now a one-to-one function because I'm artificially leaving some of it out, is what it comes down to. So if I find the inverse now, swap x and y, solve it, and I get this, except do I really get this? Okay, so let's think about what we just wrote. I'm only using positive inputs for x. Inputs are positive. So what does that tell us about the outputs, the y values of our inverse? If the inputs are greater than 0 and all we do is swap domain and range, then the outputs have to be greater than or equal to 0 too. And so when I put plus and minus, that was an error. It should just be the positives because of that's what the inputs were. We can see that on a graph much easier. If I just literally flop x and y here, then that point comes here, that point comes here, and then that point comes there. And we have this. This is the inverse. And so the only thing left to do to finish this statement, of course, is to write it the right way and call it the inverse. Something I could not do on the last problem. And then on this problem, it's the same one, except notice we're doing a domain limited to less than 0, less than or equal to. So that is really us just graphing the other half of this parabola. Now, what are my inputs? My inputs are negatives. So if I find an inverse, if the inputs are negative to the original function, then that would make the outputs only the negative ones. And once again, we can see that on the graph by swapping x and y. This is negative 1, 4, so I'm doing 4, negative 1. And I'm getting just the bottom half of the parabola, right? If I had continued it, we would have had this, and then we would have had this. But since we did not include this red part, then we don't include it here either. So what does that mean for our answer? I'm not going to redo all the work. It means that we're going to get positive and negative, the square root of x minus 3, but then we need to throw out the positives because we didn't use any positives. All right. Hope that makes sense. There's easy. If I keep talking, I might just overcomplicate things. So I'm going to move on. Which really brings us to this piece here. Sometimes we can restrict the domain of a function in a way that it becomes one-to-one and therefore has an inverse. And that's exactly what we saw happen. There were two ways. I mean, I guess technically there are more than two ways because we could have restricted it like 1 and greater. But there really were two ways of limiting our domain on this question to either the positive half or the negative half. Okay? So what kind of functions will always have an inverse? That's what is called a one-to-one function. All right. Example 6, and I think we're heading to our last. Oh, we got one more. Example 6. Does the function have an inverse function? And the answer, I think quite clearly, is no. We know it doesn't because it is not one-to-one. And we know it's parabola shaped, right? So we can very clearly just tell, based on all our previous knowledge, that it is does not have an inverse. Quickly sketching that graph, we know it's basically a graph that looks about like this. It's been shifted down to negative 6. Okay, so no fails the horizontal line test. Not one-to-one. Don't need a comma there. Not 1, 2, 1. All right. If it does, what is its inverse? It does not. If it does not, how could we restrict the domain so that it does have an inverse? And I think quite clearly the answer is we could do it two ways. We could restrict the domain on f of x to be either x to the fourth minus 6 for x's greater than or equal to 0 only, or we could have restricted it the opposite way and said x to the fourth minus 6 only for values less than or equal to 0. If I graph either of these, then it would be a function. And it would have an inverse. So that's what I meant to say. All right. Example number 7. Given this function, find its inverse. All right. So let's go old school way and do it algebraically. So y equals square root of 2x plus 4. We swap x and y. I square both sides. And finish it off. Divide by 2. I think I'm going to actually multiply by a half and distribute it through. So that would be 1/2 x squared minus 2 equals y. Everything looks great. I do this on a test. I'm a superstar, and I do not get full credit. And why not? Well, the original function, let's take a look at that. F of x equals the square root of 2x plus 4. So f of x equals, I'm going to factor out that 2 that stays inside the square root. I could pull the square root of 2 out, but then I have to do a vertical stretch of whatever the square root of 2 is, like 1.4 or something like that. And so I'm going to try leaving it in and see if I can figure this out. Okay, so normally, so I know I'm going over to -4. 1, 2, 3, 4. So I'm starting, lost my place, right here. Now my vertical is up 1, and normally I would go over 1, but now I'm going to go half of 1, right? Because remember, this 2 is a horizontal scale change, but it's an inverse. So I am going to take my horizontal, which is 1, 3, 5, and I'm going to multiply them all by a half. So I'm going to go up 1 over a half. I'm going to go up 1 over 3 halves. 1, 2, 3. And then up 1 over 1, 2, 3, 4, 5 halves. All right, so there is my function. Therefore, since I'm only doing the upper half of this, right, let's talk about the domain of this. My domain, actually I'm going to write it down here. The domain of the function are all the x's such that x is greater or belongs to the group 1, 2, 3, 4, -4 to infinity. What's my range? My range are all the y values such that they belong to the group 0 to infinity. So that means I found my inverse. And so if I'm looking at the inverse, which I'm going to rewrite as f -1 of x is equal to 1/2 x squared minus 2, then we know its domain has to be, not because I'm looking at this, but because I'm looking here, has to be exactly the same as that. So my domain would only be the x values in the group 0 to infinity, and my range, hopefully, and we'll verify this, is just the values from the domain. All right, let's graph this function, this inverse function, and see what we get. So I'm just going to graph it without worrying about domains and range. I'm just going to graph this parabola. We know it's down 2. Okay, so it should be right here. Something feels off. Let me make sure I didn't make an error. Just checking my math. Oh, I'm going to back up. I've made this problem seem harder than I should have. Let's go ahead and leave it. Let me think about this for a minute. I may end up editing this out, but maybe it's good to hear my thoughts. Let me put it back. Let's just graph what I have because I think I might be panicking before I'm ready. So we're going to go down to -2. I'm going to go up 1 over a half. I'm going to go up 1 over 1, 2, 3 halves. Over 1 up, 1, 2, 3, 4, 5 halves. Come back here. 1, 2, 3, 4, 5 halves. I'm going to go another one. That'll be 7 halves. 1, 2, 3, 4, 5, 6, 7. All right. So something is wrong. What have I done that is incorrect? Have I graphed everything correctly? Haha, no, I have not. And everybody's probably screaming at the screen. What did I do wrong? The most classic basic error. I was a dum dum. I factored a 2 out here, but I did not factor 2 out. This should have been a 2. So this black line that I created is great, except it just should have been here instead. Okay. So it would have done this. All right. Now life is making more sense. I knew something was wrong. I just couldn't pinpoint it. And that's frankly like, let's use this as a learning lesson here. I know how to do math. I'm confident in my abilities, but something wasn't working out. So what I tried to do is figure out, ooh, why is math not working here? And I tried to like justify it by thinking I made a mistake with like a logic error. When in reality, I should have trusted myself and realized I just did a bonehead mistake. Okay, now back to this problem. Looking at this, so if I had done the full parabola, right, then it would have, kept going that way. But I'm saying I should restrict my domain to values 0 and greater, which, if I just flip the black with the red, that's what I have done. The range I'm saying is, now it's wrong, right? This is supposed to be a 2. And my range is -2 to infinity. So it matches what we did sort of independently, matches with what the function is doing. So what is the inverse? I have to fix it for x is greater than or equal to 0. So that is the answer. F -1 of x is 1/2 x squared minus 2 only for x is greater than or equal to 0. That would be the answer. Okay, I made that harder than it needed to be, but it's a good illustration that math is hard, mostly when we just don't pay attention to the small details. All right, I think that's it for today. Hopefully, when I teach this in class, it will go smoother.